Today we're going to learn about the different parts of an atom. I know a lot of these classes go into a lot of detail about the experiments and that were done to discover the parts of the atom. We're not really going to focus on that aspect as much in this class this semester, but I do highly recommend that if this is something that's interesting to you, definitely look into it more because it's fascinating to see about how some of these really foundational discoveries in chemistry were made. But again, we're not really going to focus on it in that much detail. We're really just going to do a brief overview about protons, electrons, and neutrons, and briefly how they were discovered. We're going to go in order of their discovery, so we're going to start with electrons. So electrons were discovered by J.J. Thomson at the end of the 1800s, and he discovered that atoms contain negatively charged particles. And these particles have a very, very low mass. So in this image that I have on the screen, this one's a little bit more of a modern image. This isn't what J.J. Thomson would have known the atom to look like in his time, but going off of this more modern image, the electron would be one of these blue spheres that is rotating around the center of the atom. So because atoms were shown to have negative charges, that tipped scientists off right away that means they also have to have positive charges, because it was known that in general, atoms are often neutral, which means they aren't either positive or negatively charged. They can be, and we're going to talk about that a little bit later, but scientists knew that it was very common for atoms to be neutral or to not have a charge, which meant that if there's a negative charge somewhere in that atom, there also has to be a positive charge. So Thomson, the one who discovered the electrons, jumped right on it and decided to come up with his idea of how the positive and negative charges are dispersed throughout the atom. And he believed that the electrons were surrounded by kind of like a sea of positive charge, and what's known as his plum pudding model. But his student, Ernest Rutherford, demonstrated that the positive charge was actually concentrated at the center of the atom, like in the image that I have shown on the screen. And he did this through his well-known gold foil experiment, which again is really fascinating. So if you have a chance, definitely look into how he did that, because it is really inspiring to see really some of like the genius that went into discovering how these atoms are structured. But just for fun, we're going to take a look just for a moment at Thomson's plum pudding model. So this is what Thomson thought that an atom probably looked like, with electrons just kind of spread out throughout the atom and just kind of surrounded by a sphere of positive charge. And we know now, due to Rutherford's experiment, that this is not what an atom looks like. So my biggest takeaway from this, and something that I really want you to take away from not just this one example, but from chemistry in general, is that it's okay to, when you're doing experiments or trying to learn about science, it's okay to not understand everything fully. It just means that there's more out there for you to learn. And if you ever get discouraged learning about chemistry, just remember that you know more about the structure of an atom than J.J. Thomson, the person who discovered that electrons exist in the first place. I found from personal experience that it's much harder to get discouraged when you keep that in mind. So anyway, though, since Rutherford discovered that instead of being just kind of surrounding the negative charge, that since he discovered that the protons are actually in the center of the atom in what he called the nucleus, that led to the nuclear theory of the atom, which states that A, most of the atom's mass and all of its positive charge are contained in the nucleus. B, most of the volume is empty space, with electrons dispersed around the nucleus. And C, the number of protons is equal to the number of electrons, so that the atom is neutral. Remember, that's how scientists realized that there had to be positive charges in there in the first place. So the one thing that, I know I've been showing this image several times, the one thing that I think it really doesn't show very well is the drastic size difference between the particles in the nucleus and the electrons. In this image, they look to be about the same size. The electrons look to be a little bit smaller than the nuclear particles. But in reality, the protons are much, much, much larger than the electrons.